Hello, everyone. In the previous class, we finished and looked at the differences between the global and local alignment. In this class, we look at aligning two sequences and getting the best alignment possible. So what do I mean by that? See, given two sequences, let us say you have two sequences here. One is this particular sequence, ATGGG, CGT, and the other one is AG, GAG, GT. These two sequences can be aligned together in umpteen number of ways. Remember this, my statement. They can be aligned in umpteen, means different ways in which these sequences can be aligned by incorporating gaps. See, let's have a look at two of such alignments. There may be many, but I have projected only two here. For example, this is the first sequence. And what have you done here? To get the similar or identical nucleotides one against the other, you don't use the word similar for nucleotides. You use the word similar only for protein sequences. To get the identical nucleotide sequences one against the other, what do you do here? You incorporate a gap over here in the second sequence and leave this as such and then proceed forward. This is the first kind of alignment that you get. And the second kind of alignment for the same set of sequences is by incorporating a gap here instead of here and getting this and this against one another and these two against one another. We have many such alignments possible by incorporating gaps. Now, but among all these alignments, the software throws on the screen the best possible alignment. So what is the software actually doing in the background to get the best possible alignment possible? So ultimately, if I ask you a question, like how will I evaluate students in a class? You'll simply score, or you give them a test and then score. And the same thing applies over here. There are several scoring schemes by which you can evaluate your alignments and get the best possible alignment. So what do I mean here? I meant that you need a scoring scheme to get the best possible alignment by scoring the alignment. Given two sequences, we need a number to associate with the possible alignment so that each and every match can be assigned to a number and a total can be calculated. Now we'll have a look at what I exactly meant. See, now what do you have here? You have, let's say, one scoring scheme. An example is given here. You have a gap cost. I tell a gap cost because it's a negative score. And then you have a match for which you have a positive score and a mismatch for which you have a negative score. So likewise, like if this is the scoring scheme that you're using, let's now score your alignment. Let's see. See, if this and this is a match, you have a +1. And wherever there is a match, there is a +1. And when there is a gap, it is -2. And when there is a mismatch, it is -1. This is a mismatch, right? So it's a -1. And similarly, matches here, plus and plus, you have a total of around +2. And similarly, you do the same thing here and you get the total. Now, looking at the total, when you see that the first one has got a better score than the second one, it means the first one is a better alignment in comparison to the second one. And that's what the software does. The software throws the best possible alignment by scoring your alignment by using certain scoring schemes. In the next lecture, we'll have a look at the different scoring schemes.